students, today we will study about factors influencing chemical shift. First factor is inductive effect. Electron withdrawing atoms which are more electronegative, atoms like oxygen, nitrogen, halogens, they withdraw electrons from carbon and carbon in turn withdraws electrons from hydrogen. So as a result, it causes de-shielding effect on protons because electrons are being moved away from the protons. So downfield signal is obtained. In the given example, two CH3 groups are attached to oxygen and by the help of arrows I had shown electron density is moving away from CH3 group. So it is causing downward shift of the signal. So signal is downfield. In case of CH3 there is no such electronegative atom present, so it absorbs upfield than the previous compound, that is CH3OCH3. Second category of atoms are which release electrons towards the proton, not directly towards the proton, sometimes through carbon. So in this case, because electron density is being increased around the proton, so as a result of this, a curtain of electrons is being created which causes shielding effect. So as a result of this, the compound protons would absorb at higher fields. Otherwise, both kinds of inductive effects can have two kinds of fallouts. First is depending upon electronegativity or electropositivity. We are explaining just in terms of electronegativity, or rather it can be electropositivity. First is extent of electronegativity. If the atom is more electronegative, it will withdraw electrons to greater extent. So as a result, it causes more de-shielding. Second thing is the distance of electronegative atom from the proton under consideration. If it is directly attached to the proton, it will cause more withdrawal of electrons, so causing more de-shielding of the proton and downward shift of the signal. If it is indirectly attached, it is at a distance from the halogen atom, like in the given example, in case of CH3Cl, it is directly attached to carbon bearing 3 protons, A category of protons, CH3 group. There is more de-shielding. In case of CH3CH2Cl, here CH3 is being separated from Cl by CH2. So it is at a distance farther away from the first compound. So here de-shielding would be less for CH3 protons of category A. Then is second factor is anisotropic effects or space effects, which work through the spatial arrangement of electrons. Here shielding is done, shielding or de-shielding both can be observed here. So it depends upon the compound which contain it is it appears in the compound which has pi electrons, because the mobility of pi electron cloud is to the larger area than the covalent bonds. So due to this, we have studied in case of aromatic ring that the pi electrons start circulating around the protons from one end of along the molecular axis, from one end to another face of the, from one electron cloud to other electron cloud. So in a circular motion, induced magnetic field is produced at the protons in the same direction as that of the applied magnetic field. As a result, it reinforces the applied magnetic field, whereas in acetylene the induced magnetic field is in opposite direction to that of the applied magnetic field. There it causes, because it is in opposite direction, it opposes the applied magnetic field, so it causes less effective field at the proton. So more applied field has to be used because it causes shielding of the proton. So this is about compounds containing pi electrons. Similarly, in case of CHO group. In case of aldehyde, CO has pi electrons. Again, it de-shields the hydrogen of CHO group. Then comes the last factor, that is hydrogen bonding. Hydrogen bonding is due to the bonding between hydrogen and some nearby lying more electronegative atom. So these electronegative atoms again cause de-shielding of the electrons. So as a result, the signal appears downfield. So these are three factors. Inductive effect is very important. So it is applicable everywhere. Any factor that causes concentration of electrons around the protons, it shields the proton, and any factor which removes the electrons from the proton or moves electrons away from the proton, it causes de-shielding. Okay. Then there are certain general points after this. There are general points which are to be remembered, that when we compare protons of CH3, CH2, CH group, which one has more shielding? It comes to our mind that which signal would be towards TMS signal and where would be CH signal or CH2. So carbon carrying 3 protons shows more shielding. So the signal would be towards right hand side, closer to the TMS signal. So its value is delta is 0.9. For TMS, delta is 0. So closer to the TMS signal, the value is 0.9, closer to 1. So this is due to the fact that carbon is bound to 3 protons. When it is bound to 1 proton, then it tries to withdraw electrons from hydrogen, the proton. So here electrons are more closer to the carbon than proton. So here proton is somewhat de-shielded. When 2 protons are there, the same pull is on 2 protons. So it is divided between 2 protons. So both the pairs of electrons, they are somewhat closer to the hydrogens now instead of carbon. They are somewhat away from carbon. So it causes more shielding for the protons because they are lying closer to protons but away from the carbon. When there are 3 protons, now the same pull for electrons, because carbon requires same amount of electrons. Now it is divided between 3 protons. Equal pull has been divided 1/3 for each proton. So electrons move towards the proton. As a result, there is more screening of 3 protons. So it depends upon if the number of protons is more, screening or shielding is more. Then coming to second category containing carbon-carbon double bonds and carbon-oxygen double bonds. It causes de-shielding where there is pi electron cloud. Pi electron cloud tries to withdraw electrons away from the protons. The maximum impact is in aldehydes, where carbonyl group oxygen is more electronegative. As a result, CO group is electron withdrawing. So hydrogen here is very much de-shielded. So the value is delta 9 to 10, between 9 and 10. So it is on the extreme left side of the TMS signal, opposite side of TMS signal. Then comes aromatic proton. Again, aromatic ring, benzene ring has electron withdrawing inductive effect. As a result of this, the proton is de-shielded and the value of delta here is 6 to 8.5. So it is less than aldehydic proton. Then comes carbon double bond carbon of vinylic group. Even in ethylene, C double bond C here, the proton is again de-shielded due to the presence of double bond. So the value is 4.5 to 6 delta value. So de-shielding is smaller than aromatic protons. Then if we attach one more carbon to this carbonyl containing aldehydic carbon, instead of hydrogen we are attaching CH the next carbon to the carbonyl carbon, alpha carbon. Even when we attach one more carbon to benzene ring or to C double bond C, third carbon is added, then the impact on the proton of the added carbon would be less than these compounds we have just discussed. So in the next point, third point, for carbonyl carbon, the alpha carbon proton has delta value of 2 to 2.5. The effect has diminished from 9 to 10 to 2 to 2.5. Then coming to benzylic proton, benzene ring and CH, here delta is 2 to 3, almost same value. Then coming to allylic proton, 3 carbon chain with double bond on one side and proton on the opposite end. Here delta value is 1.7. Then we had just studied hydrogen bonding de-shields the proton, and electropositive atoms like silicon increase the electron density around the protons because they release their electrons towards the proton. Proton gets shielded, so it absorbs at higher values.